Pack your things, Nicholas. Your services are no longer required, and as of this moment, your custom scripts are the property of Vance Precision. Leave the server key on my desk." The VP sneered. I said nothing, grabbed my hardware token, and walked out. But the chaos had just begun. To understand how we got to that conference room, you have to understand what Vance Precision Manufacturing actually does. We are located in a gray, sprawling industrial park just outside of Cleveland, Ohio. For decades, the company survived on mid-tier machining contracts, churning out brackets, flanges, and structural components for the automotive industry. It was noisy, dirty, and barely profitable. I was hired 15 years ago, back in 2011, by the founder, George Vance. George was a real machinist, a man who had grease under his fingernails and could tell if a spindle was out of alignment just by listening to the pitch of the motor. When he hired me at age 33, he told me he wanted to transition the shop into high-precision aerospace contracts. But there was a massive problem. High-precision aerospace parts required tolerances of less than 0.001 millimeters. A single micron of error could cause a turbine blade to shred itself inside a jet engine at 30,000 revolutions per minute. To achieve those tolerances, you typically needed brand-new, multi-million-dollar Swiss 5-axis machining centers. Vance Precision didn't have that kind of capital. We were running 24 aging Herco VM30i and Haas VF6 vertical milling machines. Out of the box, those machines were built for general manufacturing, with factory tolerances that drifted up to 0.005 millimeters under heavy load, and their standard controllers were sluggish, processing G-code line by line with noticeable delays. That was where I came in. I spent my first 5 years rewriting the automation logic from the ground up. I didn't just write standard CNC programs. I wrote an entire proprietary software layer that sat on top of the machine controllers. Over a decade of late nights, burnt coffee, and thousands of test runs, that software grew into a massive 75,000-line suite of custom G-code macros, adaptive feed rate controllers, and PLC calibration subroutines. On the shop floor, we just called it the 75K code. The 75K code was a masterpiece of industrial engineering. It integrated directly with external laser micrometers mounted inside the machine cabins. Every millisecond, the code would pull the lasers, measure the thermal expansion of the cutting tool and the raw titanium block, and dynamically adjust the machine's axis coordinates and spindle speed mid-cut. It also included custom look-ahead algorithms that read the motion path thousands of lines in advance, preventing the sudden deceleration bottlenecks that wear out cutting tools. The results were staggering. With the 75K code active, our 24 old Haas and Herco mills performed with the precision of brand-new Hermla machining centers. We achieved the 0.01 millimeter tolerance consistently. Even better, because the feed rates were dynamically optimized, the cycle time for a single titanium turbine blade dropped from 84 minutes to just 19 minutes. We were running 4 times faster than the manufacturer's speed limits without breaking a single carbide tool. George Vance knew the value of my work. In 2011, when we formalized my role, we signed a comprehensive employment and intellectual property agreement. George didn't want to pay a massive upfront software development fee, so we structured a licensing deal under Section 9D titled Proprietary Automation Software License. The contract explicitly stated that the 75K code was my personal intellectual property. I granted Vance Precision a non-transferable personal license to use the software across their 24 machines for an annual site license fee of $75,000. Furthermore, once the code was fully integrated across all machines, I was due a one-time milestone integration royalty of $250,000. Crucially, Section 9D contained a termination clause. If my employment with Vance Precision was terminated without cause, the software license would immediately revoke, and all rights to use the 75K code would revert back to me. For 14 years, the arrangement worked perfectly. George paid the annual license fee, and Vance Precision grew from a local machine shop into a highly respected aerospace supplier. We were the sole source for high-pressure turbine blades for Munich Aerotech, a major German aerospace buyer. That contract alone was worth $18 million annually, representing 80% of our company's revenue. Then came 2025. George Vance's health began to fail, and he officially retired, stepping back from daily operations. The board of directors, looking to modernize the corporate structure, allowed George's 32-year-old son, William Vance, to take over as the vice president of operations. William was nothing like his father. He didn't know the difference between a ball-nose end mill and a face mill. He had a degree from a top-tier business school, wore tailored suits that looked ridiculously out of place on our dusty shop floor, and viewed the entire factory through the lens of a spreadsheet. Within his first 3 months, William hired Sarah Miller as the new HR director. Sarah was a ruthless corporate bureaucrat whose sole job was to trim the payroll. They immediately targeted the veteran machinists, replacing them with cheap, inexperienced operators. And it didn't take long for William's eyes to land on my contract. To him, paying a single engineer a $75,000 annual software fee on top of a base salary was an offensive line item. He also saw the pending $250 SOS and integration royalty, which was due upon the final verification of the Munich Aerotech production run, as a cost that needed to be eliminated. He had no idea that the 24 machines grinding out titanium parts 24 hours a day were only doing so because of the 75,000 lines of code running silently in the background. He honestly believed the machines did all the work on their own, and that I was just an overpaid IT guy who watched them run. That arrogance was about to cost him everything. The conflict began to simmer in early 2026, just as we were gearing up for the final validation run of the Munich Aerotech turbine contract. This contract was the holy grail for Vance Precision. We had spent 18 months preparing the shop floor, calibrating the tooling, and running test batches. If we passed this audit, we would secure an initial $18 million purchase order, with options to expand to $40 million over 5 years. It was the kind of deal that could secure the company's future for a decade. But to William Vance, it was just a target to maximize his personal performance bonus, which was tied to reducing operating costs by 15%. On a rainy Tuesday morning in February, I was summoned to William's office. The room had been completely renovated since his father George occupied it. The warm oak furniture was gone, replaced by sterile glass tables and minimalist white chairs. William sat behind his sleek laptop, looking every bit the modern corporate executive who had never set foot in a machine shop. Sarah Miller, the new HR director, was sitting beside him holding a thick folder. "Sit down, Nicholas," William said, gesturing to the glass chair opposite him. He didn't offer any coffee. He didn't ask how the calibration runs on the Haas mills were going. "We've been reviewing the plant's operational expenses, and frankly, some of these legacy contracts are extremely outdated, particularly this software license of yours." He tapped a printout of Section 9D of my agreement, an annual fee of $75,000 for G-code scripts on top of your 6-figure salary. That is completely out of line with current market rates. And this upcoming milestone royalty of $250,000 for integration is frankly absurd. We already pay for the machines. We already pay for the tooling. We shouldn't be paying an employee extra just to make the machines work. I kept my face neutral. The $75,000 is a licensing fee for my proprietary software, William. Your father and I agreed to it because it saved the company from spending $3 million on new Swiss machining centers. The code isn't just G-code. It's a closed-loop adaptive control system that keeps these older mills within aerospace tolerances. Without it, you cannot run at these feed rates, and you cannot meet Munich Aerotech's specifications. William let out a soft, patronizing laugh. "Nicholas, let's be real here. It is code. It is text on a screen. Our IT department tells me that once code is loaded onto a machine's memory, it's just a file. We have junior developers who can write scripts. We are going to restructure your contract. We will absorb the software license into your standard job description. We'll give you a 5% raise on your base salary, but the annual licensing fee and the milestone royalty are off the table. You will sign a waiver, transferring all copyright of the code to Vance Precision." Sarah Miller slid a 2-page document across the table. It was a formal IP waiver, couched in dense legal jargon. "It's standard procedure, Nicholas," she said, her voice dripping with artificial warmth. "We just need to clean up the company's IP portfolio before the German audit next month." I looked at the document, then looked back at William. "I won't sign this. Section 9D is very clear. The code is my personal property. If you refuse to pay the licensing fee or the royalty, you lose the right to use the software." William's face hardened. The polite veneer slipped, revealing the petulant, entitled air underneath. "We'll see about that," he muttered, closing his laptop. "That's all for today, Nicholas. Think it over." I knew exactly what would happen next. William wasn't the type to accept a flat rejection. Over the next 2 weeks, the atmosphere on the shop floor grew increasingly hostile. Sarah Miller began documenting my every move, looking for any excuse, no matter how petty, to build a case against me. The opportunity they were waiting for arrived on a Thursday afternoon. The shop was in the middle of a high-priority test run of titanium turbine blades for Munich Aerotech. Suddenly, Machine 12, one of our oldest Herco mills, triggered a thermal drift alarm. The laser sensor micrometer was reporting a discrepancy, and the spindle was starting to vibrate. If the machine kept running, it would ruin a $45,000 block of aerospace-grade titanium and potentially damage the $5,000 spindle head. Donald Weaver, our veteran shop floor foreman, ran to my office, sweat pouring down his face. "Nicholas, Machine 12 is drifting. The sensor is throwing garbage data. I need you down there right now." If we shut down the line, we miss the daily shipment and William will have my head. I grabbed my diagnostic laptop and ran down to the floor. For the next 2 hours, I was deep inside the machine's cabinet, recalibrating the optical sensor, cleaning the coolant scale off the lenses, and adjusting the PLC feedback registers. It was meticulous, greasy work. While I was covered in coolant under Machine 12, a plant-wide announcement echoed over the speakers. All staff, report to the main bay for a mandatory safety briefing. I heard it, but I couldn't leave. If I stepped away from the machine now, the thermal calibration routine would fail, and we would have to scrap the entire batch of titanium. Donald Weaver stood by, holding a flashlight for me. "Go ahead to the meeting, Nicholas. I'll try to finish it," he said. "No," I replied, tightening the sensor bracket. "If you don't calibrate this laser within the next 10 minutes, the heat expansion will ruin the cut. We finish this first." We finished the calibration. The machine hummed back to life, the alignment tolerances settling back to a perfect 0.008 millimeters. The batch was saved. But by the time I washed the grease off my hands, the 30-minute safety meeting was already over. The next morning at 8 a.m., I received an email from Sarah Miller. I was to report to the main conference room immediately. When I walked in, William Vance and Sarah were waiting. There was no discussion, no request for an explanation. Sarah pushed a folder toward me. "Nicholas, yesterday you deliberately failed to attend a mandatory company-wide safety meeting," Sarah said, her voice cold and formal. "We have video footage of you remaining on the shop floor. This is a direct violation of safety protocol and constitutes insubordination. Coupled with your recent refusal to cooperate with corporate policy, the management has decided to terminate your employment effective immediately for gross misconduct." William leaned forward, a smug, triumphant grin on his face. "Pack your things, Nicholas. Your services are no longer required, and as of this moment, your custom scripts are the property of Vance Precision. Leave the server key on my desk. We don't pay royalties to insubordinate employees." He honestly thought he had won. He thought by firing me for cause, he could bypass the licensing agreement, avoid the $250,000 royalty, and keep using my code for free. He had no understanding of how the software was actually designed, or what the contract actually said. I didn't argue. I didn't point out that I was saving a $45,000 part. I didn't tell him that his actions were a blatant violation of Ohio employment law. I just reached into my pocket, touched the physical hardware token, and nodded. "Understood," I said quietly. I signed the termination paperwork, took my copy, and walked out. I went back to my office, packed my personal manual tools into my toolbox, and walked into the main server room. The local CNC server rack was humming in the corner. I reached behind the main switch, pulled out my personal physical hardware security token, a small black USB device that handled the decryption handshakes for the 75K code, and slipped it into my pocket. Without that hardware token, the local server could no longer perform the automated licensing handshake with my private cloud server. I walked out of the building and into the cold Ohio rain, knowing that the countdown had already begun. By the time I reached my home in Cleveland Heights, the rain had turned into a steady, freezing drizzle. I didn't waste any time. I went straight to my home office, powered up my secure desktop terminal, and called Timothy Finch. Timothy had been my attorney for nearly 10 years. He specialized in intellectual property and corporate law, and he had actually helped me review the final draft of the licensing agreement with old George Vance back in 2011. When Timothy picked up, I laid out the facts clearly. I told him about the manufactured safety meeting infraction, the termination for gross misconduct, and William's explicit declaration that the 75K code was now the permanent property of Vance Precision. Timothy let out a dry, incredulous chuckle. "They actually fired you for missing a safety meeting while you were saving a $45,000 turbine blade? And they think that constitutes cause under the contract? That is laughable. Ohio is an employment-at-will state, yes, but contract law is absolute. Under Section 9DE of your agreement, the definition of cause is strictly limited to criminal acts against the company, like embezzlement or theft. Missing a meeting to perform critical maintenance doesn't even come close." "What about the software?" I asked. "William claims that because the code is loaded into their machines, it belongs to the company. He has no idea what he's talking about," Timothy said. "Section 9 is watertight. It states that the license is personal, non-transferable, and terminates immediately upon your separation from the company without cause. Since they terminated you without legal cause, the license is revoked as of the moment you sign that paper. If they run a single line of that code starting now, they are committing willful copyright infringement under Title 17 of the United States Code, Section 106 and Section 501. The statutory damages for willful infringement can go up to $150,000 per machine per day. For 24 machines, that's $3.6 million a day." I will draft a formal cease and desist letter and send it via certified mail and email to William Vance and Sarah Miller within the hour. Don't worry about the machines, I said, looking at the terminal. They won't be running the code for long anyway. Once I hung up with Timothy, I opened my development console and logged into my private Amazon Web Services EC2 dashboard. The architecture of the 75K code was designed with security in mind. I had spent years protecting my intellectual property from being stolen by competitors, and that meant protecting it from being copied off the Vance Precision servers. The software did not run as a static text file on the CNC controllers. Instead, the core optimization algorithms, the thermal expansion formulas, and the look-ahead motion paths were compiled into binary executable modules that ran on a local Unix-based edge server on the Vance factory floor. Every 60 minutes, the local edge server was required to perform a cryptographic handshake with my private secure AWS server. The handshake required a 256-bit SSL certificate and a dynamic token generated by the physical hardware security key I had just pulled out of the server rack. If the local edge server failed to perform the handshake for 2 consecutive cycles, exactly 2 hours, the software's digital rights management system would assume the connection was compromised. It would immediately uncompile the active macro libraries, wipe the active calibration cache from the Herco and Haas machine memories, and revert the controllers back to their factory default firmware. I looked at the AWS console. The local Vance Precision server was pinging my AWS server, requesting the handshake. I navigated to the API gateway, selected the Vance Precision Access credentials, and clicked the Revoke Access Keys button. The server status changed from Augur's Eyes to Access Denied. At Vance Precision, the afternoon shift was in full swing. Donald Weaver was standing near the center of the shop floor, watching the 24 mills carve high-pressure turbine blades out of solid titanium blocks. The shop was a symphony of high-frequency whines and the steady rhythmic spraying of synthetic coolant. The Herco and Haas mills were running at 400% of their standard factory speed, the spindles screaming at 12,000 RPM as the cutting tools sliced through the titanium like butter. Then, exactly at 6:15 p.m., the symphony abruptly stopped. First, Machine 12 let out a deep groaning sound as its spindle suddenly decelerated. A second later, Machine 1, then Machine 2, and then the entire line of 24 mills came to a sudden grinding halt. The coolant pumps shut off. The high-frequency whine died, replaced by the low, idle hum of the cooling fans. On every CNC controller screen, a red warning box flashed. DRM security handshake failed. Connection to authentication server lost. Clearing active optimization macros, reverting to OEM factory firmware, system reboot required. Donald Weaver walked over to Machine 12's controller. He stared at the screen, a slow, knowing smile spreading across his face. He had been around long enough to know what Nicholas's hardware token did, and he knew that William Vance had just made the biggest mistake of his life. Within minutes, the shop floor was in total confusion. The machine operators, mostly young, inexperienced hires who had only been trained to press the green cycle start button, were frantically pressing buttons and looking at each other in confusion. Donald stepped up to the main control panel of Machine 12 and initiated the system reboot. The machine took 3 minutes to restart, loading its default out-of-the-box Herco firmware. "All right," Donald told the operator. "Load the standard program and start the cut." The operator pressed the button. The spindle spun up, but it didn't scream with the high-pitched power it had minutes ago. It groaned. The machine moved sluggishly. Without the look-ahead algorithms, the controller had to pause at every line of G-code, processing the motion path in halting, jerky increments. The feed rate dropped from 40 inches per minute to just 10. Worse, as the tool touched the titanium, the laser micrometer remained dark. The local controller was no longer receiving the real-time thermal calibration updates. Within 2 minutes, the friction of the slow, uncalibrated cut caused the titanium block to overheat. The coolant began to steam, and with a sharp crack, the $70 carbide end mill snapped in half. Donald looked at the broken tool, then at the controller screen, which now read, "Error, axis out of tolerance. Deviation 0.006. Shut it down," Donald ordered the operators. "Shut all of them down before we ruin every piece of titanium in the shop." Donald walked back to his office, grabbed his desk phone, and dialed William Vance's direct line. "William, we have a massive problem. The machine's just shut down. Nicholas's code is gone, and the standard factory firmware is breaking our tools. We can't run the line." By Monday morning, the atmosphere inside Vance Precision was one of pure, unadulterated panic. The German audit team from Munich Aerotech, led by their notoriously strict chief inspector, Hans Geller, arrived at 8:30 a.m. They were there to verify the first production run of the high-pressure turbine blades. Normally, when a client audited the shop, the floor was a showcase of speed and precision. The 24 CNC mills would be humming, carving out titanium blades in less than 20 minutes each, with the laser sensors verifying the 0.001 mm tolerances on a digital dashboard in real time. Instead, Hans Geller and his team of inspectors walked into a factory floor that sounded like a salvage yard. The machines were running at a crawl, the cutting tools groaned as they labored through the tough titanium, and the operators were constantly shutting down machines to replace broken carbide bits. Geller stood in front of machine 12, his arms crossed, watching the spindle jerk along its path. He checked his clipboard, then looked at the cycle timer on the controller screen. It read, "Estimated cycle time, 82 minutes. Mr. Vance," Geller said, his voice flat and accented, turning to William, who was sweating profusely through his designer suit. "Your proposal stated a cycle time of 19 minutes per blade, allowing for a daily output of 70 blades across your line. At 82 minutes per blade, you cannot even meet 20% of our daily volume requirement. Furthermore, where is the real-time thermal calibration data on the dashboard?" William swallowed hard, looking over at Sarah Miller, who was pale and silent. "We are experiencing a temporary software glitch, Mr. Geller. Our IT team is resolving it as we speak. The machines are still running. Running is not enough," Geller replied coldly. He walked over to the quality assurance lab where the first batch of completed blades was being measured. He picked up a micrometric measuring tool, checked a finished blade, and compared it to the digital readout. "This blade has a tolerance deviation of 0.058 millimeters, Geller announced, showing the digital gauge to William. "Our contract, under Section 14, explicitly states a maximum allowable deviation of 0.001 millimeters. Any deviation above that renders the blade useless. It will fail under thermal stress. I have measured 10 blades from this morning's run. Every single one of them is scrap metal." Geller set the blade down with a loud clack. "Under Section 14 of our purchase agreement, failing this quality audit constitutes a material breach of contract. If you cannot deliver a certified batch of 500 blades with the required 0.001 millimeter tolerance by Friday at 5 p.m., Munich Aerotech will cancel the $18 million contract immediately, and we will enforce the $3.5 million late delivery penalty." As soon as the German inspectors walked out to their rental cars, William erupted. He stormed into the foreman's office where Donald Weaver was sitting, calmly drinking a cup of black coffee. "Donald, what the hell is going on with the machines?" William roared, slamming his fist on the desk. "Why are the cycles taking 80 minutes? Why are we breaking tools? And why are the tolerances off?" Donald took a slow sip of his coffee. "I told you on Friday, William, when you fired Nicholas and took his security token out of the server rack, the proprietary macros deactivated. The machines reverted to their factory default firmware. The Haas and Herco factory systems aren't designed to handle these feed rates or thermal expansions without Nicholas's code. Nicholas's software was what made these old machines run like $1 million Swiss tools. Without it, they're just old, slow mills. That's ridiculous." William screamed. "It's just G-code. I have the backup files of the programs. Load the G-code directly." "We did," Donald said, shaking his head. "But the G-code calls up custom macro subroutines, the 75,000 lines of code that Nicholas wrote. Those macros are encrypted and run on the Edge server. Without the DRM server handshake, the Edge server won't compile them. The machine controllers don't know what to do with the commands, so they revert to standard interpolation, which is slow and inaccurate." William whipped out his phone and dialed my number. I was sitting on my back porch enjoying a cup of tea and watching the snow melt when my phone started ringing. The caller ID showed William's direct office line. I let it ring. 2 minutes later, my phone rang again. It was William. I let it ring again. On the third attempt, I finally answered. I didn't say a word, I just listened. "Nicholas, you listen to me!" William screamed into the receiver, his voice cracking with panic. "What did you do to the servers? The machines are down. You sabotaged our systems. That code is company property. If you don't log in and fix this glitch right now, I will sue you for sabotage, breach of contract, and intentional damage to company property. I will make sure you never work in this industry again." "William," I said, my voice completely calm and even. "I didn't sabotage anything. I simply retrieved my physical hardware token when I was terminated. Under Section 9D of the agreement your father and I signed, my termination without cause immediately revoked the software license. If you are currently running my code or trying to bypass the security to run it, you are committing willful copyright infringement. My attorney has already sent you a cease and desist letter. I suggest you read it before you call me again." I hung up. 10 minutes later, William and Sarah Miller met with a local IT consulting firm they had frantically hired to crack the code. The lead programmer, a young guy in his late 20s, was looking at the local server console, scrolling through the encrypted binary headers of the 75K code. "Can you bypass the handshake?" William demanded, hovering over the programmer's shoulder. "Can you write a script to simulate the security key?" The programmer looked up, staring at William as if he were insane. Mr. Vance, this isn't a simple WordPress plugin. This is 75,000 lines of highly complex, low-level assembly macros and custom mathematical algorithms that integrate with laser hardware. The binaries are compiled with a rolling key encryption. To reverse engineer this and write our own calibration formulas from scratch would take a team of 4 senior automation engineers at least 6 to 12 months, and it would cost you upwards of $300,000 in development fees alone. And even then, we might not get the thermal calibration formulas right. The guy who wrote this is a genius. You can't just copy it. Sarah Miller looked at William, her face completely drained of color. William, if we don't get that code back, the German contract is gone. And if the board finds out we got hit with a $3.5 million penalty because we fired our lead engineer to save $75,000, we are finished. William stared at the screen, his mouth open. Realizing for the first time that his MBA could not compile the code, by Tuesday morning, the situation had escalated beyond William's control. Munich Aerotech's legal team had formally sent a notice of breach, and the news of the impending contract cancellation and the $3.5 million penalty reached the company's board of directors. The board, composed of major shareholders and longtime allies of the founder, was horrified. They immediately contacted George Vance, who was recovering from a minor cardiac event at his winter home in Florida. When George heard what his son had done, his blood pressure spiked, but his mind remained as sharp as a diamond-coated insert. He caught the next flight back to Cleveland, arriving at the factory at 7 a.m. on Wednesday. Donald Weaver met George at the entrance. Donald spent 30 minutes explaining the entire situation, the attempted contract renegotiation, the IP waiver William tried to force Nicholas to sign, the fabricated safety meeting infraction, the immediate shutdown of the CNC line, and the failed German audit. George didn't even go to the executive office. He walked straight into the plant manager's office where William and Sarah Miller were frantically trying to draft a lawsuit against me. George slammed the door so hard the glass pane rattled. "Get out," George told Sarah Miller, his voice low and vibrating with rage. "You are fired. Pack your desk and leave the property immediately. If I see you here in 10 minutes, I'll have security escort you out in handcuffs for fabricating employment records." Sarah didn't say a word. She grabbed her purse and ran out. William stood up, his face turning red. "Dad, you can't do that. She was just following my instructions. Nicholas sabotaged the systems. We are suing him." "Nicholas didn't sabotage anything, you idiot," George roared. "He took his property back because you tried to steal it. You fired our lead engineer, the only man who knows how to make these machines run, 2 days before our biggest audit, all to save a measly $75,000 and boost your own bonus. You've put this entire company, my life's work, on the brink of bankruptcy." George pointed a finger at his son. "You are stripped of all operational authority. You are done. The board has approved your transfer. You are going to Casper, Wyoming to manage our third-party storage warehouse. You will count inventory. If I catch you near a CNC machine or a software server, I will personally see to it that you are written out of my will. Now get out of my sight." An hour later, George called me. His voice was tired but warm. "Nicholas, it's George. I'm back in town. I need to buy you lunch." We met at the local Heights Diner, a quiet place we used to visit when we first started the company. George sat in a corner booth, a thick white envelope on the table. "I'm sorry, Nicholas," George said, looking me in the eye. "I built this company on hard work and respect for the trades. I should have never let William take over operations. He's got a degree in business but doesn't know a damn thing about value. I fired the HR woman, and William has been permanently transferred to a warehouse in Wyoming." He pushed the white envelope toward me. "Inside is a new agreement, drafted by our corporate counsel. It's already signed by me and approved by the board." I opened the envelope and reviewed the terms. George's legal team had accepted every single one of my conditions. 1. Vance Precision would pay the unpaid $250,000 milestone integration royalty immediately. 2. The company would pay a $90,000 severance package, representing 6 months of my salary at $15,000 a month, as compensation for the wrongful termination. 3. The software license for the 75K code was reinstated under a new 5-year contract, but the annual site license fee was doubled from $75,000 to $150,000. 4. I would return to the plant as an independent external consultant, billed at $500 per hour, with a minimum retainer of 10 hours per month, solely to perform software updates and maintain the API integration. Attached to the contract was a certified bank check for $340,000, the royalty plus the severance. "The check is cleared, Nicholas," George said. "We just need the code back. The Germans are leaving on Friday. If we don't pass the audit, we're done." I signed the contract, took my copy, and slid the check into my pocket. "Let's go fix your machines, George." At 1 p.m., I walked back onto the shop floor of Vance Precision. The operator stood in silence, watching me walk toward the server room. I unlocked the rack, plugged my physical hardware security token back into the Edge server, and opened my laptop. I logged into my AWS dashboard, reauthorized the local server's IP address, and generated a new set of 256-bit API access keys. Within seconds, the local Edge server completed the cryptographic handshake. In my terminal, the status bar turned green. DRM authentication successful. Compiling macro libraries. Deploying G-code calibration registers. System active. On the shop floor, the 24 CNC mills rebooted. Donald Weaver watched as the custom macros loaded back into the Haas and Herco memories. "Load the titanium block," Donald ordered. The operator pressed the green button. The spindle spun up, its pitch rising to that familiar high-frequency scream. The machine moved with fluid, high-speed grace. The look-ahead algorithm read the path, the laser micrometer flashed inside the cabin, and the spindle adjusted dynamically. 19 minutes later, the machine stopped, and the cabin door slid open. The finished turbine blade sat in the fixture, gleaming under the coolant spray. Donald carried it to the quality lab. Hans Geller and the German inspectors watched as the coordinate measuring machine scanned the blade. The digital readout flashed. Tolerance deviation, 0.0006 millimeters. Geller let out a low whistle. Incredible. That is well within our requirements. The speed is back and the precision is perfect. Mr. Vance, the audit is passed. We will sign the contract. I stood in the background, watching William pack his cardboard boxes into his car in the rain, while his father George shook hands with the German client. Today, I am 48 years old and fully retired. The $340,000 check went straight into my investment portfolio. Every year, Vance Precision pays me $150,000 just to keep the 75K code running on their machines. And I receive a wire transfer for $5,000 every month for my consulting retainer, even if I don't set foot in the plant. William is still in Wyoming, counting boxes in the freezing cold. I sometimes think about his smug faces in that conference room, telling me my code was just simple scripts. It turns out, 75,000 lines of code can build a company, and it can tear it down just as fast if you don't know how to respect the man who wrote it.